In this video, we are going to learn about how to resolve a force into two perpendicular directions and question related to equilibrium. First, let's see how to resolve a single force. So when you resolve a force, so you can replace the original force with any other alternative two forces, but those two forces should be perpendicular to each other. So when we resolve a force into two perpendicular directions, then we can let go the original force and it will be easy to use those resolved forces in our calculation. So for this 10 newtons that create 30 degrees with the horizontal, the ideal directions which are perpendicular would be along the x direction, which is going to be horizontal, and the other one will be towards the vertical. Now when 10 newton is resolved into the horizontal or the x direction, what you would get is the cosine version of this 30 degree. So the answer for the horizontal component of this 10 newton force once resolved is 10 multiplied by cos value of this 30 degrees. And if you want to find the vertical component, that will be, which is along the y direction, that will be 10 multiplied by sine value of 30. So it's easy to memorize. What you should do is 10 cos 30 when you're going through the angle. When you're going away from the angle that they have given, it will be sine. So when you're going through the angle, it will be cos. When you're going away from the angle they have marked, it will be sine. So this 10 newton, original 10 newton that create 30 degrees with the horizontal, can be replaced with the force 10 cos 30 along the x direction. That will be 10 times cos 30. That would lead to 5 root 3 newtons. And the other one will be sine 30 would be half. The answer for that will be just 5 newtons. So that means a force that is acting 10 newtons with an angle of 30 degrees to the horizontal has the same effect as two forces which are perpendicular to each other acting 5 root 3 on horizontal direction and 5 newtons on the vertical direction. Why do we do the resolving? It's easy when it comes to applying F equals ma or any other equation of motion. So when you apply F equals ma, it's a must. We need to consider a certain direction. It could be horizontal, it could be vertical. So rather than having a complex version like this, we can straight away use 5 root 3 when you are resolving horizontally, or 5 newtons when you are resolving vertically. We will be discussing about that later on in another different video. So let's see how to resolve this 10 newton that creates 30 degrees to the vertical. So the concept is really simple. What you should do is think of two different forces that can replace this 10 newton. So when you go through the angle, it will be cos. It will not be sine. Keep in mind, when you're going through the angle, the marked angle, it will be cos. So we are going through the angle, so it will be 10 cos 30 this way, and the other angle will be, when you're going away from that, it will be 10 sine 30. So the answers will be the same as the previous, but they are gonna get flipped. So 5 root 3 will be appeared here, and 10 sine 30 would be just 5 newton. Now let's look at the next question. Here the 10 newton force is acting towards that point. It's not going away from the point like the previous instances. So, but the theory is still same. So what you're going to do is, we're going to replace this 10 Newton that is acting 30 degrees to the vertical. It's acting 30 degrees to the vertical. So we can replace it by using two other different forces. One would be acting straight away downwards, and the other one all the way going from left to right. So we can let go this 10 Newton and think about alternative two forces that would be identical, that would create a similar effect on this force. So 10 Newtons, when we do the resolving, it will be 10 cos 30 because we are going through the angle, and this 10 Newton, when you're going away from the angle, it will be 10 sin 30. The value is gonna be same. So 10 cos 30 will be 5 root 3 Newtons, and the other one will be 10 sin 30. Sin 30 will be half of them will be 5 Newtons. That's how you resolve a single force. Now, let's see how to find the resultant force for these three questions. So now, instead of having just one force, you have two forces. So let's read the question. Find the magnitude and direction of the resultant force acting on each of the particles shown below. So pause the video for 4 minutes and try this question by yourself. Okay, now let's see how to answer the first question. When it comes to a question related to mechanics, it's vital that you draw a diagram. So let's copy the same diagram. Let's say A. So there's a point over here and a force of 25 Newtons acting, creating an angle of 50 degrees to the horizontal, and another one which is 35 Newtons making an angle of 30 degrees. Now let's see how to find the resultant force. That means we are going to find a single force that can replace these two forces. So in order to find that single force, what we could do is we can find the force which is gonna be acting on towards the x direction, and we can find the other part of that single force acting towards y direction. So then the resultant force would be the combination of both x and y, and let's see the angle that it creates. So first of all, let's try to resolve these two forces in upward direction towards the y direction. So you can say resolving in upward direction. So let's take that y Newton to be the component of the force, resultant force acting towards y direction. So that y is gonna be equal to 25. So now we are going away from the angle, so it will be 25 sin 50 plus and 35 sin 30. Y is going to be plus because it's supporting the direction that we consider. We are trying to resolve the upward direction, assuming that the resultant would be in that direction, the y component. So it doesn't matter whether the direction that you take is perfectly correct, because if your assumption is wrong, it would come with a negative answer. That means instead of the y component acting upward, it could be acting downwards if your final answer is minus. or the negative. So this is going to be 35 sine 30. Now your answer is going to be, type this one straight away in the calculator, 25 sine 50 is going to be 19.15 plus, I will write straight away in the calculator so that I can get the answer. So this is going to be, my final answer will be 36.65. Rather than split it into two parts, I just typed everything in one go. So this is the vertical component that's acting in that direction of the resultant. So let's resolve these two forces in horizontal direction. So in this direction, so the force that we are going to consider, the component, the resultant in that direction will be X. So what are the forces acting in that direction? It will be 35 cos 30, because we are going through the angle, so it will be 35 cos 30. Now if you look at the other angle, it will be 25 cos 50, but it is opposing the direction that we considered. So you can put a minus because it's going against the direction that we assumed at the beginning. It will be 25 cos 50. So once you get the final output using the calculator, it will be 35 cos 30 minus 25 cos 50. So my answer is going to be 14.241 newtons. Now I managed to find the horizontal component and the vertical component of this force, but in this question they're asking us to find the resultant force. So to find the final single force that can replace both 25 and 35, we can do this calculation. So we have a force of 14.24 newtons acting in horizontal direction, and a vertical component of that resultant force is 36.65. I just rounded into 2 decimal places. Now I'm going to reverse the process that I did earlier. That means splitting a single force into two components, vertical component and the horizontal component, can be reversed. How can we reverse that? We can use the Pythagoras theorem. So all what you need to do is, in order to find the resultant force, you can apply Pythagoras theorem, because this is same as, let's say, 36.65 is same as finding the hypotenuse created by these two forces. So we can find the resultant. So resultant force is gonna be, it will be 14.24 squared plus 36.65 squared and square root the answer. That will be your resultant. So use a calculator. It will be square root of 14.24 squared plus 36.65 squared, and your answer is gonna be 39.31. So your result will be 39.319 newtons. I'm not worried about the accuracy because this is not an exam question, but I'm worried about how would you tackle this question. So I think you understood how to do it. So you can have a go with the other two as well if you got stuck earlier. If not, let's check the answer for part B and part C. Now Normally when they ask you the resultant force, just we found the resultant force, but it would be good if you can find at what angle this resultant force is acting, because just giving the resultant force to be 39.31 might not be enough, because from the same point over here, instead of having those two forces, you could have 39.319, but we don't know which direction it's working, to which direction. So you can easily find the angle that it creates to the horizontal or the vertical by using simple trig calculation. So if you want to find this theta, let it be theta. So you can see that this 36.65 is gonna be opposite side of this right angle triangle. At the same time, this 14.24 would be the adjacent of this right angle triangle. So opposite and adjacent is linked with tan. So you can straight away write tan theta. Let me zoom it. Tan theta is going to be 36.65 divided by 14.24. So in order to find the angle, it will be tan inverse. So straight away type in the calculator. It will be tan inverse 36.65 divided by 14.24. Then your answer is gonna be 14.24. Your answer is 68.76 degrees. So now we know the specific value of the resultant and we know the specific direction. So the meaning of that is this 25 newtons and 35 newtons can be replaced with a force of 39.319 with some other value which we just truncated, which is acting 68.76 degrees to the horizontal direction. So your final answer can be replaced the two forces that we mentioned earlier like this. So your resultant force is gonna be acting force is gonna be 39.319 newtons acting 68.76 degrees to the horizontal, 68.78 to the horizontal degrees to the horizontal. That's your resultant force. Likewise, if you do answer for part B and part C, you should get an angle 27.9, a force of 27.9 and creating an angle of 16.2 to the horizontal. And if you try the same technique to part C, your answer should be 3.01 newtons, creating an angle of 53.3 to the horizontal. Now, we just learned how to resolve any number of forces to find the resultant. Now, what if these forces are in equilibrium? So, now let's read this question. Three forces act upon a particle as shown. Given that the particle is in equilibrium, calculate the magnitude of P. Now, these three forces are in equilibrium, but there are two unknowns. We don't know what the value of P is. That's a question mark, and we don't know the angle that it creates with the horizontal, which is theta. But we have 140 newtons and the angle it creates with the horizontal, and we have 100 newtons and the angle it creates with 30 newtons. So how to answer a question like this? what you could do is, you can write a statement like this. Since the system is in equilibrium, since the system is in equilibrium, all the forces acting upward, which is horizontal direction, and all the forces acting all the forces acting vertical direction, which is upward, and all the forces acting in horizontal direction, which is along the x-axis, would add it up to 0. So you can write a small symbol which is known as sigma and mention that all the upward forces acting in y direction would sum up to 0. So let's try to resolve these three forces into y direction. So let's go around. So here 140, start with 140. What's the vertical component acting in that direction? So 140, we are going away from the angle. This 45 is here, so the angle, the vertical component that it creates will be 140 times sine 45. Since sine 45 is exactly half of 90 degrees, it doesn't make a huge difference, but keep in mind, since this 45 is evenly split, degrees evenly splitting this 90 degrees, the both horizontal and the vertical component will be equal to each other. That means 140 sine 45 or 140 cos 45 would be the same answer. But since we are resolving in the y direction, you need to write sine 45, 140 sine 45, and let's see what would be the vertical component of the other force, which is 100 newtons. So 100 newtons vertical component would be 100 sine 30 because we are going away from the angle, and it will be plus as well because it's supporting the direction that we considered earlier. It's not a must to consider upward always. You could consider downward, but once you consider downwards, you need to make sure that your sign's gonna be different. It will be negative for both these forces. Now what about the other force? I have P, but now P is opposing the direction that we considered because P is acting downwards. So its vertical component would be minus. So that's gonna be minus P. Is it cos or sine? It is going away from the angle, so it will be P sine theta. So since all these three forces are in equilibrium, there is no resultant either in horizontal direction or the vertical direction. So this will be added up to 0 newtons. So you can rearrange it so that you can create an equation. So it will be P sine theta. I'm sending this way. I'm rewriting it, taking P sine theta to the left, and the rest it will be 140. Sine 45 is root 2 over 2, and 10 sine 30 is, it's not 10 actually, it's going to be 100. Not a mistake, it will be 100 sine 30. Sine 30 is going to be half. It's going to be half. So try to simplify. My answer is going to be 70 root 2 plus 50 would be the vertical component of this P force. Now similarly, we'll try to resolve in horizontal direction, so we can draw the direction that we are trying to resolve. So we can say sigma x. Sigma stands for the sum of all the forces acting in x direction, so that will be added up to 0. Why does it add up to 0? Because still the system is in equilibrium. Now let's see how to resolve it. So what are the forces acting in that direction? I have 100 sine 30, not sine actually, it's going to be going through the angle, so it will be 100 cos 30 minus, why it is minus? Because this 140 would be opposite in the direction, it will be 140 cos 45. It is minus because it's opposite in the direction we considered. 140 is acting in that way. And how about this P force? This P force has a positive effect on the direction that we consider, so it will be plus P cos theta, because we are going through the angle, it will be cos. That will be my equation. Now rearrange it, so it will be P cos theta. I would send 140 cos 45 is root 2 over 2 minus 100 cos 30 is root 3 over 2. So my answer would be P cos theta is 70 root 2 minus 50 root 3. These are my two equations. Now what I could do for these two equations is, I can bring down this first equation right underneath like this and try to solve it. So how can I solve these two equations? If you look carefully, I can divide equation maybe 1 by 2. If I divide 1 by 2, my left hand side will be, I'm dividing the red color one by the black color equation, so it will be P sine theta, you divide by P cos theta. The benefit of doing that is one of the variable is going to get cancelled. Here P is going to get cancelled straight away. Now write the red color bits on top because it's the first equation I considered. 70 root 2 plus 50 divided by 70 root 2 minus 50 root 3. Now use your calculator. Sine divided by cos will be tan theta. It will be the same thing that's gonna get repeated, so I'm gonna copy that one. I'll be writing here, and my theta is gonna be tan inverse of this number, so tan inverse, which is gonna be, type it in the calculator, tan inverse 70 root 2 plus 50 and 70 root 2 minus 50 root 3. My answer is gonna be, it creates 85.245 degrees to the horizontal. So theta is 85.245. The question says, given that the particle is in equilibrium, calculate the magnitude of P. So they are expecting us to find the value of P. So still I'm halfway through it. So I can use that answer to solve one of the equation. So I'll copy down the equation 1 to my next part of the calculation, because they are only asking the magnitude of P. I'm gonna get down that equation here. Now we all know the theta value is 85.245. 85.245. Now let's see how to find P. So P is gonna be 70 root 2 plus 50 divided by sine theta. Sine theta is gonna be 85.245. So my P is gonna be, type everything in the calculator, 70 root 2 plus 50 divided by sine 85.245. My answer is gonna be 149.509. So We'll give the answer into 3SF, because normally you need to give the answer into 3SF. So it's going to be 150 newtons would be my answer. So that's the magnitude of P. I hope it is clear. So the only difference between when a system is in equilibrium and when we are finding the resultant force is that we equate all the forces in the horizontal or the vertical direction to zero if the system is in equilibrium.